So I have a question. Anisha would like me, she says, instead of only doing the problem set, can you please quickly go over important information from the chapter? Okay, so I have built this problem set so I can basically introduce the main elements of the chapter. Okay, so I am going to go over the problem set only, but I'm gonna stop at some questions and to remind you what is the important information you need for solving that question. Okay, so in particular, if you look at the first question of the problem set, which is a graph, and basically it asks you where the profit is maximized. Okay, so before I'm going to solve that question, I'll just basically introduce the information you need to know to solve this kind of question, and I'm gonna go back to how a firm decide what output level to choose. Okay, so I'm gonna start by that. So here, what I'm gonna do is to analyze the profit maximization of firms. So what I'm gonna do hold for both price taking firms and price making firms. Okay, so this is a very general analysis, and this is going to hold for both under perfect competition and also for monopolists. So the basic idea is, I'm gonna write at the same time. So you have a firm who is going to sell a certain level of output. So a firm sells output Q.
Sorry, would it be possible to zoom it in a bit?
Yeah, so what are you seeing? Okay. Wait, maybe I can just do that. Is that bigger or not?
Thanks, that's perfect.
Okay. All right. So the firm here is going to sell a certain amount of output Q, and the revenue it gets from selling this output comes from the sales, and we are gonna call it RQ. Okay. Sometimes it's called TRQ, but here I'm gonna just put RQ. Okay. So that revenue is going to depend on how much output is gonna be sold. Okay, so it's going to depend on Q, but it's also going to depend on the market price. Okay, so basically the higher the market price, the higher the total revenue is going to be. All right, so the firm gets some revenue from its sales. On the other hand, the firm must produce a good, and to produce that good, it incurred costs. Okay, so we are going to call the total cost, sometimes we call it TC, but well, let's call it C here. So the total cost is going to depend on the level of output you're going to produce. Okay. In general, total costs are going to increase with the level of output. The more you produce, the higher the costs. All right. So we have total revenue, we have total cost. Now, the objective of the firm will be to maximize its profit. Okay, so basically, the firm wants to make this difference between total revenue and total cost the greatest possible. So formally, we are going to write the firm economic profit. Okay, again, here we talk about an economic profit, not an accounting profit. We call it pi usually, and this is going to depend on the level of output Q. Okay, so the economic profit is going to be the difference between total revenue, which depends on Q, and total cost. So really, the purpose of the firm is to make the difference between total revenue and total cost the greatest possible here. Okay. So concretely, what we want to do is to find the best level of production, Q star, the optimal level of production that's going to make this difference the highest possible. Okay. So how are we going to solve this? I'm going to introduce two approaches. First, the graphical approach, and second, an approach based on calculus. Okay, but basically, if you get the graphical approach, then we'll get the calculus pretty quickly. So, okay, graphical approach. So, graphical approach to profit maximization. So I'm gonna draw a graph here. So the first graph I'm going to draw will have the quantity of output on the horizontal axis. So here you have Q. And on the vertical axis, you have two things. We're gonna draw two curves. So the first curve is gonna be total revenue, and the second curve is gonna be total costs, okay? So what do we know about this curve? So we know that in general, total revenue is going to increase with your sale, okay? So as you increase your production, the total revenue is going to increase, okay? So here, let's call it R of Q. So here I did draw like a concave function of Q, okay? So when you increase your output level, your revenue increase, but at a decreasing rate, okay? Another option would be to draw like a straight line, okay? That's two options for total revenue. I'm gonna get back to when do we have a concave function and when do we have a straight line a little bit later. All right, so we have total revenue. Then we're gonna draw the total cost function, okay? So what do we know about total cost? So total cost, again, remember, it's the sum of the fixed cost and the variable cost. So when the firm produces nothing, so when Q equals 0, then the total costs are gonna be equal to the fixed costs, okay? So here, my y-intercept is going to be FC, fixed costs. Okay, when I produce nothing, I have to pay the fixed costs. Okay. Then I start to produce a certain amount Q. And I'm gonna get this kind of curve, like a cubical curve. So this is a typical shape of the total cost curve, okay? So what can we read from that graph? So first, you can see, I'm gonna take another color, that, so let's call this point Q1, and that one Q2. Okay, so if you look at the range of output between 0 and Q1, what can you see? What can you conclude about the level of profit? Well, you can see that the total costs are above the total revenue, okay? So in this area here, your profit are gonna be negative, okay? Then between Q1 and Q2, total revenue are always higher than the total cost, okay? So in this area here, your profit is going to be positive, okay? And then again, you reach Q2, and above Q2, your profit are gonna be negative again, okay? So from this graph, you can guess that the optimal amount of output Q star that you're looking for is gonna be between Q1 and Q2, okay? It's gonna be in the range where the profit is positive. So before I get to the condition that guarantees that the profit is positive, I'm gonna draw a second graph just below that one. Okay, so on that graph, I'm going to draw the profit function. Okay, so I'm gonna put quantity on the horizontal axis and profit on the vertical axis. So when the quantity produced is 0, we said that the firm incurs fixed cost. Okay, so the amount of profit when Q equals 0 is minus FC. Okay, then the profit is negative until I reach the point Q1. In Q1 here, let's call it point A. In point A here, total revenue exactly equal to total costs. So the profit is 0. Okay, so I'm gonna cross the horizontal axis here. Okay, and I know that I'm going to cross the horizontal axis again in Q2. Okay, why? Because my profit turned from positive to negative in Q2. Okay, so in B here, I know that my profit will turn negative again. Okay, so if you look at the shape of the profit function here, it must be the case that between Q1 and Q2, my profit function reaches a maximum. Okay, so for some level of output Q star here, I know that I will get the highest possible profit. Okay, so what is the condition on my first graph here, which implies that I'm going to reach the maximum profit in my second graph? Well, we're going to look at the slope of the total cost and the total revenue curve. Okay, so here, so the profit is positive. In that area here, the profit is positive. So again, I want the profit to be the greatest possible. So I'm going to look at where the difference between R and C is the highest possible. Where does it occur? Well, it occurs, let's say, it's somewhere here. So I'm going to get Q star here. And it's going to occur where the slope of the total revenue curve is going to be the same as the slope of the total cost curve. Okay. All right, so this is the slope of this is the slope of the total revenue curve. Okay, how do we call the slope of the total revenue curve? Someone? Okay, no one? So the slope of the total revenue is what we call the marginal revenue. Okay, so each point of the slope of the total revenue curve is the marginal revenue. So I'm going to call this marginal revenue. Okay, so basically the marginal revenue tells you the revenue you get from selling an additional unit. Okay, all right, so here we have the marginal revenue. Now let's look at our cost curve. How do we call this the value of the slope here? Someone?
Marginal cost.
Marginal cost. Okay. What is a marginal cost? Well, it's the additional cost from producing one more unit of the good. Okay, so the optimal level of output Q star will be such that the marginal revenue here is going to be equal to the marginal cost. Okay, so when the slope of the total revenue is the same as the slope of the total cost, then we know that profit is maximized. Okay. So what happened when, let's say, for instance, I'm here. Okay, let's say that I'm in Q prime here. What happened here? Well, let's draw the slope in that point. So here, so let me write that down. So in Q prime, the slope of the total revenue is lower than the slope of the marginal cost. Okay, so marginal revenue is lower than marginal cost. So what does it mean intuitively? It means that the revenue you get from selling an additional unit on the market is lower than the cost incurred by producing that additional unit. Okay, so when marginal revenue is lower than marginal cost, then it is optimum. The firm will optimally reduce its production. Okay, so now let's look at the opposite case. Now let's assume that I am in Q double prime here. So in Q double prime, what happened? Well, you can draw the slope in that point for both total revenue and total cost. So you can see here that the marginal cost, so the slope of the total cost curve is lower than the slope of the total revenue curve. So marginal cost is lower than marginal revenue. Okay, what does it mean? It means that producing an additional unit and selling it on the market get me an additional revenue which is higher than the additional cost of producing that same unit. Okay, so if the marginal revenue is higher than the marginal cost, then the firm is going to optimally increase its production. Okay. All right, so the only point where the firm actually maximizes its profit will be where marginal revenue is equal to marginal costs. Okay. Do you have questions on the graphical approach to profit maximization? Okay, so I have a question here. Yeah, all right. Because that's the calculus approach. So I'm gonna move to the calculus approach to this. Okay. All right. Okay, so we are going to state formally what is the problem of a firm. So the problem of the firm, I'm going to write it as a profit maximization problem. So the problem is to find the quantity Q. So I put it below max here. I want to find Q that is going to maximize the following function, pi Q. And pi Q is R of Q minus C of Q. Okay. So given that I get this function, how do I get the maximum here? Okay, what is Q star that maximizes the profit here? Well, we know that the first order condition is going to be that the derivative of the profit function with respect to Q must be equal to 0. Okay. In other words, the slope of the profit function in Q star is going to be horizontal. And if you look at our second graph here, you can see that the maximum is reached when the marginal profit here, so the slope of the profit function here is 0. Okay, so this is a condition we are looking for. All right, so I'm going to put here P prime with respect to Q is 0. Okay, so that's a necessary condition. It's not sufficient. Okay, but for now we're just going to focus on that condition. All right, so let's take the derivative the profit function. So we're going to get the derivative of total revenue with respect to Q minus the derivative of total cost with respect to Q must be equal to 0. Okay. But what do we know about D of R over D of Q? Well, this is marginal revenue, okay, by definition. So we have marginal revenue minus D of C over D of Q is marginal costs. And this is going to be equal to 0, okay? So just rearranging this equation, we know that in optimum Q star, I should put Q star everywhere here, marginal revenue equals marginal cost. Okay, so that's what we have shown on the graph. Okay, profit is maximized with marginal revenue equals marginal costs. Okay. Do you have question on this? All right. Okay, so that's do I have question? No, okay. So that's an important aspect of this topic, okay? Do I have something else to tell you about that? Well, not for now, okay? So now that you know everything about profit maximization, we can go back to the first question. Okay. And so again, this analysis on profit maximization is going to hold for both price-taking firms, so firms that don't have any market power, so firms that just sell their output and have no impact on the market price. And it's also going to hold for monopolists, okay? The only difference between price-taking firm and price-making firm will be here on the marginal revenue, okay? So the value of the marginal revenue will have a specific value in the case of price-taking firm and another value in the case of a monopolist, okay? All right, so let's go back to this first question. So we have a graph. At which point or range is profit maximized? Okay, so now you know everything about profit maximization. So you know that you're looking for the point where the slope of the total revenue function is equal to the slope of the total cost function. Okay, so here you can draw the slope of this function here. And you know that here profit is maximized. Okay, so here you know that in point B you get the maximum possible profit. Okay. Question: what happens to the profit?
Wait, so
yes.
why not point C can be maximizing though?
That was my question. What happened in point? Let's say C. What happened in point C? Okay. So let's write it down. So at point C, well, from the graph, you can see that total revenue is equal to total costs. Okay, so what does it mean? Well, it means that the profit, which is total revenue minus total cost, is 0. Okay, so when the two curves crosses each other, well, you reach a 0 profit. Okay, so it occurs in point C here, and it occurs in point A here as well. Okay. Question. Okay, so if there is no question, yeah, no profit. So in A and C, no profit. in point B, profit is maximized. Okay, again, you can see that the distance between RQ and CQ is the highest possible. All right, so let's move to the next question. So here, in this set of questions, we are going to focus on price-taking firm. Okay, so price-taking firm are the firm you're gonna get when you study perfect competition. Okay, so basically the firm has no power on the market price. It's just going to observe what is the price on the market of its output, and it's gonna sell its output at the market price. Okay. And we will see that being a price taker has implication on the shape of the marginal revenue curve. So question 2, so A, complete the table. B, determine the profit maximizing level of output. And C, what is the market price and its relationship with average and marginal revenue. All right. So we're going to start by completing the part of the table that relates to the costs, okay? Because we are familiar to that. All right. So I'm gonna start with let's say a fixed cost. Can someone tell me what the fixed costs are? Yeah. So how do I get the fixed costs? Well, the fixed costs are the costs I'm going to pay even if I don't produce anything. Okay, so I'm just going to look at the level of output of 0, and I know that the total cost here are going to be the fixed cost. Okay. All right, so fixed costs are 5. So I'm going to put that for any level of output. All right. Okay, so now we can fill in the marginal cost. Okay, so the marginal cost is the incremental cost of producing 1 additional unit. Okay, so when I produce 1 unit, my total cost moved from 5 to 7. So the incremental cost is 2. Okay. When I produce 2 units, my incremental cost is 11 minus 7, which is going to be 4. When I produce 3 units, my incremental cost is going to be 17 minus 11, which is 6. When I produce 4 units, marginal cost is 27 minus 17, which is 10. When I produce 5 units, it's 41 minus 27, which is 14. And the last one is 20. Okay. So you can see that as I increase output here, total cost is increasing. Now let's fill in the average costs. So what is average cost? Well, it's total cost over Q. Okay. Okay. So when output is 1, it's 7 divided by 1. Okay, so that's 7. When Q is 2, average cost is 11 divided by 2, which is 5.5. Then we have 17 divided by 3, which is 567. Then we have 27 divided by 4, which is 675. Then 41 divided by 5, which is 8.2. And the last one is 10.70. Okay. All right. So now let's move to the revenue part of that table. Okay. So we have total revenue. So total revenue, what is total revenue in the case of a price-taking firm? Well, total revenue, TR, is the number of units sold on the market times the market price. Okay. So here we know that this number here are Q times P. All right. So how do I get average revenue? Well, average revenue is going the revenue per unit. Okay, so you take total revenue and you divide it by Q. Okay, so let's do that. So when Q is 1, total revenue is 10. So 10 divided by 1 is 10. When total revenue is 20, I produce 2 units. So average revenue is 20 divided by 2, which is 10. When total revenue is 30, I'm producing 3 units. So again, average revenue is 30 divided by 3, so it's 10. And you can continue like this. Okay. Now let's turn to the marginal revenue. So the marginal revenue is the additional revenue you get from selling an additional unit. Okay, so that the change in total revenue when you move from 1 to 2 units, 2 to 3, and so on. So the marginal revenue here is going to be 10. Again, 10. Here, 30 minus 20, which is 10. 40 minus 30 is 10. 50 minus 40 is 10. And 60 minus 50 is 10. Okay. So what do you observe by looking at the average revenue and marginal revenue here?
Can I ask a question?
Yeah.
Is this always the case, or like it just happened to be this problem that marginal the average revenue and the marginal revenue have to be equal to 10, 10, 10?
Yeah, okay, so that's the observation, okay? So here you can observe that average revenue is going to be equal to the marginal revenue, okay? Which is equal to 10. I'm going to answer your questions. What can we say about the market price? How can we get the market price from that table?
Market price is 10.
Market price is 10, okay? You can use total revenue. Let's say you look at here. You know that if total revenue is 30, you produce 3 units, so the market price has to be 10, okay? So here, average revenue is equal to marginal revenue, and this is equal to the market price, okay? And that's going to be the case for a price-taking firm, okay? And that's intuitive, right? So a price-taking firm just observe the market price. The market price is 10. I'm the firm, I'm going to sell an additional unit on the market. So what is the marginal revenue? The additional revenue I get? Well, that's 10, that's the market price, okay? Whatever the level of total revenue I'm having, okay? So if the marginal revenue is constant and equal to the market price, then it must also be true that my average revenue is gonna be 10. Okay, on average, I get always the same amount by selling an additional unit on the market. Okay. Okay, so we have answer C, we have answer A. We still have to answer B. Let me check. Oh yeah, no, I'm not done with this. Okay, so let's be formal just a little. So when you have a price taker, okay, so the profit function is going to be, as usual, R of Q minus C of Q. But because the firm is a price taker, R of Q is going to be P times Q. Okay. So now you're thinking, what else could it be? Well, it could be P of Q times Q, okay? I'm gonna get to that later. So here, if you calculate the average revenue is RQ over Q. Well, that's P times Q over Q, that's P, okay? So you can formally show that average revenue is equal to price. What is marginal revenue? Marginal revenue is a derivative of total revenue with respect to Q. Sorry, I forgot that. Okay. So what is the derivative of P times Q? Well, that's P. Okay. Hence our relationship here. All right. Okay. So let's answer the sub-question B here. What is a profit maximizing level of output? So what do we know about profit maximization? Well, we have just seen that. We know that the firm is going to determine Q star such that marginal cost equals marginal revenue. Okay. So what is marginal revenue here? Well, marginal revenue is 10. Okay. So we are going to look in the table in the marginal cost column where we have a marginal cost of 10. Okay. So here, when total output is 4, when I produce 4 units, my marginal cost is 10, my marginal revenue is 10. So I have no incentive to increase the production further, and no incentive to decrease the production. Okay. So here, answer to question B. The profit maximizing level of output is Q star equals to 4. All right.
Can you please repeat that?
Say again.
Can you please repeat the part where you found the answer B?
Okay. So for B, what you're looking for is the quantity Q star such that marginal cost equals marginal revenue. Okay. So you know marginal revenue is 10. So you're going to look in the marginal cost column here where the marginal cost is equal to 10. Okay. It happens here. And so you just need to read what is the level of output for that marginal cost. Okay.
Okay.
You can also calculate the profit. Something else you could do, you could calculate the profit here, which is total revenue minus total cost. Okay. And you just look at the output where the profit is the max, and it's going to happen here. Okay, but it takes more time. All right. Okay, question on this? Okay. Okay, let's move to question 3. Suppose we plot the total revenue curve with quantity on the horizontal axis and revenue on the vertical axis. Okay, I'm gonna do that right now. Okay, so I'm gonna put quantity on the horizontal axis and total revenue on the vertical axis. On the price-taking behavior, price-taking, so total revenue curve should be. Okay, so what can we tell about the total revenue curve if I know that the firm is a price taker? So let's write down our equation for total revenue. Okay, we said total revenue is simply equal to P times Q. Okay, so what is the shape of total revenue? Well, this is an affine function of Q. Okay, so when I sell nothing, I'll get no revenue. When I sell 1 unit, I get a revenue equal to P. When I sell 2 units, I get a revenue equal to 2P, and so on. Okay, so the shape of the total revenue curve is going to be a straight line passing through the origin, and whose slope is going to be what?
-1.
Oh, well, that's positive. Okay. Positive 1. Well, so let's write the equation of any affine, any linear equation. So AX plus B. Okay. So what is X here? That's Q. Okay. What is B here? Well, it's 0. Okay. That's why the curve passes through the origin. What is A here? Well, that's P. Okay, so for price-taking firm, the total revenue curve is going to be a line of slope equals to the market price. Okay, it's just P times Q. If you sell 4 units and the market price is 3, then you get 4 times 3. Yeah, we are no longer dealing with the previous table, okay? But you're right that if we want to get the equation of the total revenue for question 2, okay, so for question 2, the equation of total revenue would be, well, the price was 10, right? 10 times Q. Okay. Okay. All right, so what is the answer here? The answer is a straight line from the origin with slope equal to market price. All right. So what does it mean when we go back to question 1 here? Well, it means that for that question, we were not talking about a price-taking firm. Okay. Why? Because the shape of the revenue function here was concave. And for a price-taking firm, we have the shape of the revenue curve that must be a straight line. Okay. All right. So let's move to question 4. The perfectly competitive firm's marginal revenue curve is, okay. So we have just talked about the total revenue curve, and we just said it's a straight line with a slope equal to P. What is a marginal revenue curve for a price-taking firm? Someone? Any idea?
Straight line.
It's going to be a straight line. We need to be more specific. Horizontal, vertical, with some slope, or
Horizontal.
exactly. Okay, so if we want to relate to the previous graph here, what is the marginal revenue in that graph? Well, the marginal revenue, I would say Q, but it doesn't depend on Q here. And it's equal to P, okay, the slope of the total revenue curve. So whatever the level of production, the marginal revenue is going to be P, okay, so it's a constant. So if I were to draw the marginal revenue here, I would draw an horizontal line, and the value here on the vertical axis would be P. Okay. All right. So the answer here is horizontal. Okay. So we know profit maximization. We know what is total revenue and marginal revenue for a price-taking firm. Now we're going to move to how to determine the shop realm supply for a price-taking firm. Okay. So first, we are going to determine the location of the profit maximizing quantity when you are given this kind of graph. So what do you have on that graph? Well, you have the cost function, marginal cost, average total cost, and average variable costs. You have also the demand curve. Okay, so here the demand curve is horizontal because the firm know that it's gonna sell each unit on the market at the market price. Okay, so here the demand is simply the market price. Okay, so given that figure here, let's look at question 5. What is the profit maximizing number of sacks when the price of coffee in the market is $3.80? Okay, so we are told here that the price on the market is $3.80. Okay, so we are here. How do I determine the optimal quantity here? Someone? You always use the same rule. Okay, so what was the rule? So the rule is marginal revenue equals marginal costs. Okay, because we are dealing with a price taking firm, you can also say that the rule is price equals marginal cost. Okay, so price taking. So we'll say that P, which is marginal revenue, equals MC. Okay, so you're gonna look at the quantity where the price curve, the demand curve, is going to intersect the marginal cost curve. Okay, so it occurs there. Okay, so here price equals marginal cost, and you can read the corresponding quantity on the horizontal axis, and that's 22. Okay. Question on this? All right. So the answer here is 22. C. Okay. So let's move to question 6. When profit is maximized, the total revenue of the farmer equals. Okay, so how do we solve this? Well, we know that total revenue, so we want to calculate total revenue for a specific quantity, which is Q star, and we know that's 22 now. Okay, so we know that this is P times Q star. Okay, so what is P here? Well, P is given here on the graph. It's 380. And what is Q star? Well, we have just found it in the previous question. It was 22. Okay, so here total revenue is 380 times 22. And that's going to be 8,360. Okay. All right. So it's not part of the question, but now I would like to show you how we can find total revenue on the graph. Okay. So to find total revenue on the graph, well, you just look at, well, price times quantity. Okay. So what is the price? Is 380 here. I'm gonna take this. Okay, so that's 380 here. And you multiply that by the quantity, which is 22. Okay, so total revenue on that graph is simply this area here, this yellow area here. Okay, that's total revenue. Okay, so you don't take into account the costs. Question on this? Right. Okay, so now let's move to question 7. When the farmer's profit is maximized, total cost equals. All right. So again, we are gonna look at what happened when profit is maximized. So when Q star is 22, and we want to calculate total cost here. Okay, so the thing here is that we don't have the total cost function on the graph. Okay, we have only average total cost and average variable cost. Okay, so let's write down the total cost equation. So we know that total cost we know that average total cost are equal to total cost divided by quantity, because we are in the optimum, quantity is Q star here. Okay, so what is ATC here when Q star is 22? Well, you can read on the graph here the value of the ATC. So this is 283 here. Okay, so what is total cost? So total cost is equal to Q star times ADC in Q star. So that's 22 times 283. And this is 6,226. Okay, so answer C here. Okay. Now let's say that we want to represent this, this total cost on the graph, the value of this total cost on the graph. Well, you can use this equation here, okay? Total cost is quantity times ADC in that quantity. Okay, so so you're gonna go until Q equals 22 here, and you're gonna move up until you reach the value of the ATC for that quantity. And this area is going to represent the total cost. Okay. All right. Question 8. When the coffee farmer maximizes profit, how much is his profit? All right. So how do we get the profit? Well, that's easy. We have already calculated total revenue and total cost. Okay, when Q is 22, I'm gonna put 22 here as well. Okay, so total revenue was of 8,360 minus total cost, that's 6,226. Okay. Okay, and the difference is 2,134. Okay, so that's answer B here. All right. Okay, so do you have question on this? All right, so in the next question, we are going to represent the profit on the graph, okay? So an easy way to visualize the profit on this kind of graph is to rewrite the profit function as follows. So usually you set profit is RQ minus CQ, okay? Now let's say, let's put P times Q minus CQ. Let's say that you factor out Q, okay? So you will have Q times something. So for the total revenue, you have P times Q, and minus, what do you need here to get total cost? Well, you put average total cost of Q, okay? because you remember that Q times average total cost of Q is total cost. Okay, so this representation is convenient because here you can see that you multiply the quantity of output produced times the profit per unit. So that's the profit per unit. Okay, and if we want to see that on the graph, well, I'm going to take Q, so Q is 22 here, and I'm going to multiply that by P minus ADC. So P minus ADC is this distance here. Okay, so that's P minus ADC. Okay, and you're going to multiply that by Q. Okay, so your profit, the value of your profit on the graph is this area. Okay. Okay, so that's Q, and that's, let's write it, P minus ADC. Okay. All right. Do you have question on this? Okay. All right. So let's move to question 10. What is the shutdown price? On the figure, draws a short-run supply curve of the firm. Okay. So first, what is the short-run supply curve of the firm? So we said that optimally, the firm is going to produce such that price equals to marginal cost. So when the price is 380, as in the previous question, then the firm optimally responds by producing 22. Okay. Now imagine that the price is, let's say, 304. What is the best response from the firm? Well, you just look for that level of price where we intersect the marginal cost curve. And this is going to give you the optimal quantity. Okay, so what is the supply curve of the firm here? Well, this is simply the marginal cost curve. Okay, so for each price level, the firm optimally reacts by setting the quantity such that price equals marginal cost. Okay. So there are two things to consider. Okay, so what is the optimal response of the curve? Well, set price equals marginal cost, it gives you optimal quantity. But then there is another aspect of the problem that we must take into account. Okay, so in particular, imagine that the market price is, let's say, here. Okay, let's say it's 100. Okay, so the question is it worth it for the firm to produce anything given that the market price is 100? Well, you can see that for that price, the average total cost is higher than the price. Okay, so if the market price is 100, then the firm is going to make losses. Okay, why? Because price is lower than the price per unit. Okay. However, in the short run, sometimes the firm may be better off still producing something rather than nothing, okay? And we want to determine the level of price such that the firm is going to produce something, although it's gonna get a negative profit, okay? So I'm gonna show you that now. So, shutdown price. So what do we mean by shutdown? So by shutdown, we mean that the firm, if a firm shut down in the short run, then it's not going to get out of business, okay? But it is going to set a production level equal to 0, okay? So sometimes it's better for a firm to not produce anything in the short run, but to stay on the market. So shutdown price. So how do we get that price? All right, so imagine that the firm produces nothing in the short run. So what is the value of the profit then? So let's call pi 0 the value of the profit when you don't produce anything. So this is going to be P times Q minus variable cost minus fixed cost, okay? So we know Q is equal to 0, so this is going to be equal to 0. The variable costs are also equal to 0, okay? So in the short run, the firm who doesn't produce incur a negative profit, which is equal to minus the fixed cost, okay? When will a firm produce something in the short run, although it makes negative profit? So a firm is going to produce a positive amount of the good. Well, if the profit it gets from producing a positive amount is higher than the profit when it produces nothing. Okay, so let's just rewrite that. So we're gonna get PQ minus VCQ minus FC. This must be higher than minus FC. Okay, so the firm is going to produce a positive amount if this inequality holds. So the minus FC cancel out here. So we end up with PQ minus VCQ higher than 0. And we want to express that with something that is convenient. So we are gonna do VCQ over Q. And what is VCQ over Q? Well, that's the average variable cost. Okay. So in other words, the firm is going to produce a positive amount in the short run, although it is making losses, if the market price is higher than the average variable cost. Okay, so basically, the firm might be better off producing a positive amount in the short run, although it is making losses. Okay, so what is, and we call that, sorry, the shutdown price. Shutdown price. Okay, in other words, if by producing the firm cover its variable cost or more than cover the variable cost, then it's going to produce something. So what is the shutdown price in that problem? Well, the shutdown price is going to be the minimum of the ABC here. Okay. Oops, sorry. Shutdown. Okay, so in other words, so we said that for price above the shutdown price, the firm optimally reacts by producing along the marginal cost curve. But if the market price falls below its shutdown price, then the firm is going to produce a 0. Okay, so when you draw the short run supply of a firm, there is really two parts. The first part is that one. Okay, below the shutdown price, I produce nothing. The second part is above the shutdown price, I produce along the marginal cost curve. Okay. All right. So so the short-run curve is marginal cost curve. Yes, that's a question. So the short-run supply curve for an individual firm is a marginal cost curve if it produces something. And it's this small portion here below the shutdown price on the vertical axis if it doesn't produce anything. There is really two parts to the curve. You shouldn't forget about that one, okay? All right. Okay, so let's move to question 11. So here, basically, we are about to solve the same problem, but using equation instead of using a graph, okay? So in question 11, you are given the short-run total cost of the firm as a function of the quantity produced. And it says, if this firm behaves as a price taker, what is the equation of the short-run supply? Okay. The second question is, what is the equation of the shutdown price? Okay, so let's start with A. All right, so what do we know? Well, we know that in the short run, the firm set quantity, optimal quantity, such that P equals marginal costs. Okay. So we don't have the marginal cost, but we have the total cost. How do we get the marginal cost? Well, we take the derivative of the short run total cost with respect to Q. Okay, so that's 0.2. Oh, there's a Q missing here. Okay, so 0.2 Q plus 5. Okay, so that's the marginal cost. Then the firm set P equals marginal cost. So you're gonna set P equals 0.2 Q plus 5. All right. So if you want to express it as a function of P, you just inverse the equation and you end up with P equals 1/5. Q equals 1/5 of P minus 25. Okay, so that's the short run supply given this total cost curve. Okay, so you can actually use either this equation or that one. Okay, so that one gives you how the firm optimally vary quantities as the price changes. Okay, which makes more sense. Okay, but if you want to represent it as a graph, you're gonna use that one. Okay, so here the supply curve is something like this. Okay, short run supply. Okay. So again, this equation gives you for each price level, what is the optimal quantity produced by the firm. Okay, that the individual supply curve. So question B, what is the equation of the shutdown price? Okay, so we have just said that the shutdown price PS, let's call it PS, is going to be the average variable cost. Okay, so what is the average variable cost? Well, it's the variable cost over Q. Okay, so what is the variable cost here? So the variable cost is a part of the total cost equation that depends on Q. Okay, so basically that's 0.1 Q to the power 2 plus 5Q. That's the variable cost. Okay, so you're going to just plug this in the equation, plus 5Q, and divide it by Q, and you end up with 0.1 Q plus 5. Okay. So here,
Professor,
yes.
sorry, is the P on top of the P5 or S?
Where
5.
that's a S, yeah. Shutdown price. Yeah. Okay. So here's the shutdown price. Well, it depends on the quantity produced, and it starts again at 5 here, but the slope is smaller. Okay. So the shutdown price is like this. Okay, so if you look at the graph here, you can see that the shutdown price is always going to be lower than the short-run supply of the firm. Okay, so it will never be the case that the firm is going to shut down. Okay. All right. Okay, let's move to question 12. A company produces card boxes. The market is competitive, which means the firm is price taking. Okay, so we have the price selling for 100 per thousand. The firm total and marginal cost, actually, there's only the total cost. So the firm total cost curve is this. And the first question says, what is the equation of the marginal cost curve? Okay, so that question is easy. You have the total costs. How do you get marginal cost? Well, you take the derivative of total cost with respect to Q. Okay, so marginal cost is going to be 0.002 Q. Okay, that's the marginal cost. So question B, calculate the firm's profit maximizing quantity. Is the firm earning a profit? Okay, so what do you do here? You use the magic formula, marginal revenue equals marginal cost. Okay. We know that for a price taker, marginal revenue is the market price. So price equals marginal cost. So what is the price? Well, it is 100. And the marginal cost, we have just derived it. It's 0.002 Q. All right. So if you rearrange this equation, you will end up with Q star equals 100 over 0.002, which is 50K. Okay, because everything is in 1,000 here. Okay. All right, so we have the optimal quantity here. Now the question is the firm earning a profit? Okay, so let's calculate the profit. So the profit in Q star, so the profit when Q is 50,000 is P times Q minus minus total cost. So total costs are 3 million minus 0.001 q to the power 2, so 50,000 to the power 2. Okay, so this is 100 times 50,000 minus 3 million minus this. Okay, so that's 5 million minus 3 million minus 2.5 million. Okay, and this is going to be minus 500. Okay, so is the profit positive? Well, no. Okay, so profit is negative here. So question C, analyze the firm's position in terms of shutdown condition. Should the firm operate or shut down in the short run? Okay, so we know that the firm should operate in the short run if the price is higher than the average variable cost. Okay, so what is the average variable cost here? So that's the variable cost divided by Q, and the variable costs are this. Okay, so that's 0.001 times 50,000 to the power 2 divided by 50,000. Okay, so that's 50. So should the firm operate in the short run when we know that the price is 100? Okay, and this is higher than AVC, which is 50. Okay, so yes. Do you have question on this? Let me check the chat. Nope. Right, so where are we? So basically, we have done all the question that relates to price-taking behavior. Here, I suggest that if you have time, that you go over the book problem 8.6. If you need the solution, I can provide it to you, but ask me, okay? Otherwise, I'm not gonna do it. And the remaining question from 13 to 16, I believe. Yeah. A question for firms that are not price taker. Okay, so you're gonna see here that the marginal revenue will have a different meaning for this kind of firm. So I'll suggest, because we are running late, that you continue to work on that on your own. Don't hesitate to send me an email or whatever if you have questions on that. And otherwise, I wait that you answer this question on Piazza. And as usual, I'm gonna post the full solution next Tuesday, okay? Do you have question? Are we moving on to chapter 9 next week? I believe so. Let me check what chapter 9 is. Syllabus. Right, so chapter 9 is perfect competition in a single market. So yeah, next week we are gonna cover perfect competition. We are basically almost done with profit maximization. You just need to review the marginal revenue for non-price taking firm on your own. Okay, and if you don't review it, that's not a big deal, because when we will go over monopolies, I'm going to talk about it again. Okay, so try to solve the remaining question on Piazza. If you have questions, don't hesitate to send me an email. If you need the solution for the suggested book problem, send me an email as well. Again, if you don't ask, I'm not going to do it. Otherwise, I'm going to post the solution of last week's problem set by tonight. I'm running a little bit late with that. And I think that's pretty much it. Do you have other questions for me? Nope. All right, guys. Stay healthy. Have a nice day. Enjoy the inside of your apartment as much as you can. And I'll see you in a week. Bye. Thank you.
Thank you.
Will the housing market crash? I'm not doing macro. Sorry, I can answer that. Probably not. Okay, see you. Bye-bye.